Okay, this is sort of a continuation of falling objects. In particular, we're going to consider this time objects that have an initial velocity, either up or down. Unlike the previous presentation where we had just dropped the object in with zero initial velocity. So looking at this one, it's thrown downward with an initial velocity of 20 meters per second using acceleration due to gravity 10 meters per second squared. So the acceleration and the velocity are going the same direction, which makes it a little easier. We want to find the velocity and the distance traveled in 1 second intervals for the first 2 seconds of motion. So for second number 1, our velocity equals velocity 0 plus, in this case, gt, because we're talking about gravity. And then we're going to plug in what we know. We've got our 20 meters per second plus our gravitational constant of 10 meters per second squared times 1 second. And so it's going to pick up by 10 meters per second, and you're going to have 30 meters per second. Now, as far as distance traveled, distance is equal to our initial velocity times our time plus 1/2 gt squared. So we got our 20 meters per second times 1 second plus 1/2 times 10 meters per second squared times 1 second quantity squared. Then you're going to run that through your calculator. So you're going to say 20 times 1 plus 1/2 times 10 times 1 squared. And so you're going to have traveled 25 meters in that first second, primarily because of the initial velocity it was given. After 2 seconds, we're going to do those same calculations again. We can go through it a little bit more quickly because we can just follow our previous format, but we're going to have 20 meters per second plus 10 meters per second squared times 2 seconds. So 2 times 10 is 20, 20 plus 20 is 40, so we're going to have 40 meters after 2 seconds. And then our distance is still v0t plus 1/2 gt squared. And so it's going to be 20 meters per second times 1 second plus 1/2 times 10 meters per second squared times 2 seconds squared. So this is at 2 seconds, not 1 second. So then we got 20 times 2 plus 0.5 times 10 times 2 squared. We've traveled 60 meters after 2 seconds. But that's assuming that these two are going in the same direction. Now, if we essentially take same problem, except now the ball is thrown upward with that velocity, but the gravitational constant is always straight down, it changes the problem up because the velocity, initial velocity and the gravity acceleration are in opposite directions, but the math is pretty much the same. So v is equal to v0 plus gt. So 20 meters per second plus 10 meters per second squared and 1 second. But the difference is we have to make this 10 meters per second negative because we're operating in opposite directions. So now I'm only going 10 meters per second squared because it's slowing down, or 10 meters per second, excuse me. Because it's going, the acceleration is in the direction opposite the initial velocity, and therefore it's going to slow down as a function of time until it reaches its peak. The distance traveled won't be as much as in the initial problem. So we got 20 meters per second times 1 second plus 1/2 times 10 meters per second squared times 1 second squared. But again, this is negative. And so we're going to say 20 minus 0.5 times 10. And so you've only traveled 15 meters, where in the previous example it was 25 meters because it's slowing down. So for that second time interval of 2 seconds, essentially do the same stuff again. So you're going to have 20 meters per second plus your negative 10 meters per second squared times 2 seconds, which means it's now going 0 meters per second, which means you are at the peak of the throw. After that, it would fall. So our distance is v0t plus 1/2 gt squared. And it's 2 seconds plus 1/2 your negative 10 meters per second squared and 2 seconds squared. And so then you got 20 times 2 minus 0.5 times 10 times 2 squared, which is 4. And so it travels a total of 20 meters up before it begins to fall. So this has been a brief discussion of falling objects with initial velocity. That is, they've been thrown upward or downward, and the differences between them.